Okay, so Unit 1 in Industrial Material, it's just an introduction to tell you what are industrial materials and how do we select them for product design, okay, to develop new product or redesign a product. Okay, so industrial materials are nothing but the materials that we use to make products. So earliest tools that we use, they were made from eoliths. It's just an archaeological term. So commonly we just call them the rocks shaped by the forces of nature, because you can find them everywhere on Earth. So at that time, we use them for hunting and protection. Then we try to shape the stones by striking them together. So that's the beginning of making tools or products. So we made hand axes, scrappers, weapons, and so many other tools that we use for survival. So here in this picture, there's my right here. So here in this picture, you can see this is the it's kind of like the earliest tool that long time ago people used, okay, for hunting. Because at that time we didn't have knife or arrows or things like that, and we also don't know how to make something. So we use whatever we found in the nature, and this is one of them. Striking the stones together to make tools, that happened like after so many years later, okay? So this one first and then this. And then we discover fire. So out of the natural rocks and then the stones, we started to use fire. So that discovery of fire led to the use of materials and called ceramics. So it's really, really important, ceramics, because of this material we made cooking utensils and we made storage vessels out of it. So it's a very important material for human civilization. And also the discovery of fire led to other discoveries. Okay, so that's the discovery of use of pure metals easily found in nature, like copper, gold, silver, and iron. So this iron comes from the space rocks, okay? Not human synthesis. Is just something that you can find in nature, in the rocks, of course. So discovery and use of pure metals. So first we found fire, and then we found metals. So the use of pure metals, we started to develop mining, okay, out of it. And then the discovery that these metals, pure metals, right, could be mixed with one another. And that's the starting point of using alloy. Okay, alloys are cheaper than metals. We discovered that we can mix them up, yeah, without losing their properties. So metallic properties. And then we produce other materials out of that. So human inventions, innovation, discovery, from all of that, right, early beginnings, they have led to a world of materials technology that we use today. And materials technology, okay, allow us to explore the universe and continuously improve our standard of living on Earth. So right now, we already know it's not a single universe. We have universes, okay? And it's one of our location is in one of the universes. So we call you will see that in the world we start to use the term multiverses instead of universe. Okay, so that's about the materials a long time ago, okay? And how we get to the point of materials technology. Okay, so this is just a review to point out the earliest metals that we use by humans. There are only 4 of them because we can find them everywhere at that time. So that's copper, and then gold, silver, and then iron, okay? Meteoric iron. We call that the space rock iron, okay? Then, when you think about the industrial materials, you have to know 2 types, right, of resources that we get these materials from. One of them is the renewable resources. So renewable resources can be quickly replaced by natural ecological cycles, okay? By using sound management practices. I just call it like best management practices or best practices. You can replace them. So just try to know renewable resources are those you can replace quickly. So they include wood products, and then the natural fibers like cotton, silk, polymers, okay, polymers made from plants, like rubber, okay, natural rubber from the trees, rubber trees. And another resource type is non-renewable resources, and so these resources are, you cannot replace them quickly, okay? You cannot replace them by natural ecological cycles at all. And they are totally finite, meaning like they won't last forever. And they will be depleted, okay? And because of this fact, if you think about the automobile industries, we're running out of fossil fuels. So to solve that issue, we have to move to electric vehicles, okay, instead of gas vehicles. And why do we have to do that? Because of this, okay, because we're using our cars to run on non-renewable resource, which is your fossil fuels, and they are totally finite. Okay, and the next one is your inorganic minerals like copper, iron, okay. They're also non-renewable resources, and you can find them in the mineral ores. So every time you try to refine, alright, the raw materials from the mineral ores, you need energy. And also waste always come out, okay, from the refinery, and that just mess up with your environmental agencies, okay, because it messes up the weather and things like that. Okay, so 2 things in resources that you have to know. The first one is your renewable resources, and the second one is non-renewable resources. Okay. Alright. So when we design products, okay, or we redesign or design a new product, we have to consider many factors. And we can group these factors into 2 main groups. One is the social, and the other one is the economical. So economic factors and the social factors. So every time you design products, you have to consider these factors. And so product design and redesign is usually initiated, okay, from the general market research. So we study the market demands or trends and customer requests, okay, through surveys, and also listen to the customer's ideas, internal and external customer ideas. So from all this information, we design a new product or we update an existing product. So in that process, the factors, right, that influence the design process and selection of, again, materials, the industrial materials, in significant ways are all these: science and technology, consumer spending patterns, your economics, your general demographics, your age, gender, ethnicity, so and so, and competition. Okay, so these are all the factors that can influence the product design process and also the selection of materials to develop that product design. Okay, we don't just make the product in the way somebody wants it. Okay, we make the product in the way majority of the market wants it. Okay, why? Because if you don't do that, you can't sell your product. Okay, and so there is continuous customer requirements research going on, okay, all year round, and it goes by quarterly. Right, always listen. Okay, throw one product and then listen. Can we sell them? The consumer, do they like it? Is it popular? What kind of issue we have? All of that, and you have to study that, and we do study systematically, right? And that's why American products lead the world, right? Everybody want to buy iPhone, everybody want to buy computers, Microsoft, cars, etc., etc. So these factors are so important. Okay, very general. There are many details in each group, but for chapter 1, we're in introduction, so we're not going to get into details. And if you get the general, okay, idea of the factors, you're all right. Okay. So we're in the process of developing new product lines, okay? And one of the approach that we use to improve that process is called concurrent engineering. So in order, for your product to be successful in the market today, we need a reduced time, okay? And reduced time, that's it. And the least amount of time that it takes from product concept, to the production of that product. Okay, so if you can come up with a product concept and you can produce that product in the shortest way, you're going to beat all of your competitors in the market. Okay, so the time is a key, all right, factor for your product to be successful in today's competitive market. So we use a special method called concurrent engineering. Okay, so this approach is used to design the new product. Okay, why? Because we can do two processes at the same time in this method. One is the development of the product, and the other one is processes relating to manufacturing of that product. Okay, so you're developing and you're also developing the related manufacturing and support processes at the same time. So when the design is ready, everything that you need to manufacture that product processes are also ready to make that product. So this approach is designed to offer what we need, the reduced time to market. And that's pretty critical for the competitive advantage in the market. So a lot of the manufacturing company use it, and you will hear this concurrent engineering term again and again. So if you hear it, you now know what are we doing. We're developing the product, we're developing the processes necessary to manufacture that product at the same time. Why do we do that? To reduce the time it takes, from concept all the way to production of that product. So in order to do this method, we need a team. You can do or develop a product alone. You have to work with a team, huge team. Also, it depends on the size of your product. So, and the complexity of your product design. So the team, the size of your design team depends on what your product is. So the team consists of product design engineers, process engineers, manufacturing engineers, marketing specialists, and the business people, business management people. So you have to work together in order to get your product into the market. So decisions about materials, manufacturing processes, assembly methods, costs, etc., etc. And these decisions are made by this team. So consensus is nothing but the agreement. I'll write it down here for you. The agreement, all the agreement that you made within the team. So there's a lot of talking, thinking, brainstorming, and negotiations for a product to be successful. So designing the product and the process at the same time definitely shortens the time, to get that product into the market. So this ability of that method, concurrent engineering method, to design and simulate the performance, and we heavily use the computers. You are in industrial technology, so today we use the computer programs, right, to do this process. And it is a major factor to shorten the time from concept to production. Why? Because we use the industrial technology, which is the computer programs. And with these programs, we can design, we can simulate, whatever that we want to design for the new product or updating an existing product. So two things. One is the use of concurrent engineering. Second, we use the computers in concurrent engineering. And our ambition is to shorten the time. What time that we're trying to shorten? The time it takes from the product concept all the way to production of that product design. All right. So computers, we use computers to develop new products or update the existing products. So these computers, they allow us to quickly build the prototypes. Prototypes is nothing but like you need a model, right, to take a look at your design, and we don't just go ahead and build it with real materials. since we have simulations and computer programs, we use them virtually to virtually develop the design. So that's what we call it prototypes. And rapid prototyping is nothing but by using the computer, we can come up with the prototype in a fastest way, without involving any kind of industrial materials to do it. So that completely influenced our product design process. So this method, rapid prototyping, it can influence the product design process more than long time ago traditional prototype modeling method with real material, because it used a technology known as stereolithography to produce a prototype in a very, very short time. So stereolithography is just a big word. It's just a process, and that's used to create 3D plastic prototypes. And we use programs, and we call that the computer-aided drafting, your CAD, computer-aided manufacturing, your CAM, and your computer-aided engineering, your CAE. You will see this too, right? Often, but people don't use this CAE a lot. That's like behind the scene, long time ago stuff, name term. So anyway, it's a stereolithography. We use it to produce a prototype, and we can build the prototype very quickly by using this method. So in stereolithography, this process uses lasers. So here it's a rapid prototyping machine, an example, right? So it uses a laser and optical scanning, chemistry, and then the computer technologies. So right now, if you think about rapid prototyping, you should recall stereolithography machine, and in this machine there's a process that we use, and in that process we use the laser, optical scanning, chemistry, and our computer technologies. So if you can come up with that, you're quite okay. And the key point is rapid prototyping is really good because it can come up with a prototype in a very short time. And we're not using the real materials to build the prototypes like long time ago. We're actually using plastics. So we're developing a new product line or updating an existing product. And so in product design, the selection of material is really important, because if you choose a raw material, for your product, then you're going to have issues in manufacturing of that product and also marketing of that product. So there are conditions that we seriously consider. So those are the conditions in which a product is expected to perform while in service. And we look at two major things. One is its operational conditions, and the other one is environmental conditions. So for operational conditions, we take a look at the tension, the compression, the fatigue, all these mechanical forces. And you have to choose the right material to satisfy all of that in your design, according to your design. And then for environmental conditions, we take a look at the heat, humidity, and then the oil spray contact, everything that can affect the environment in which your product is going to be used. We consider all of that, If you don't consider, you're going to have an issue choosing the appropriate industrial material to make that product. So everything in the world is made of material, a certain type of material or mix, all right, materials. So if you look at your room, you're gonna see there are so many things around you, right? So the water bottle is made of plastic sometimes, right? Sometimes it's made of glass, okay? And that's kind of expensive water bottle, right? You can see some of them at stores or gas station, right? You have to pay more money to get water bottle with glass, made of glass. So anyway, so you will see everything in your room is made of some type of material, and they're all different materials: wood, plastic, ceramics, metals, okay, alloys, all kinds of stuff. And you don't want to make something that is not very important with very expensive material, because it's not appropriate, it's not the right material, okay? So that is what we think when we design a product, okay? And almost all of the product designs are carefully calculated with specification. You know, I'm going to teach you what specifications are in future slides. So everything is perfectly calculated for each product design, okay? And if we do the new product, then you will have to calculate in order to differentiate the new product from the rest of the product in the market, okay, existing market. So the material selected got to have, all right, the desired properties that you want to ensure that your product is going to be reliable. So if you're making the product, okay, with the wrong material, then your product is not going to do the function it's supposed to be doing. So, okay, it wouldn't be reliable. So the reliability is in formal term is just a degree of probability, okay, that your product is going to function as specified for service for the intended life of that product and without failure, okay? We don't want any product that we design to fail in function that's supposed to be doing, okay? So reliability is so important, and that reliability is completely depending on the material you select to make that product, okay? So therefore the selection, material selection is so important. So here are the factors, okay? These are all general terms right there that we always think, okay, in selecting the material for a new product design. So their properties, cost, source, and environmental impact. So let's get into them one by one. So if you think about the properties in selecting materials, all right, we look at 3 different properties. One is the mechanical properties, in which we think about and calculate hardness, tensile strength, compression strength, wear, stiffness, shear, impact resistance, and so on and so. So physical properties, we think about the characteristics of materials, okay, when they interact with light, the phenomena, the natural phenomena, heat, electricity, and magnetism, because they're just out there in the nature. So whatever you develop got the material, is made of materials, and these materials will definitely interact with the natural phenomenon we have in this world, okay? So we got to think about the physical properties. And then we think about the internal, the chemical property, the composition, corrosion resistance, flammability, etc., etc. Okay? Mechanical, dealing with all forces. Physical, interaction with the natural, okay, phenomena outside. Chemical, the composition of that material, okay? Got to be thoroughly thought out for the material selection to make or build a new product. All right. Cost. Cost is something that we think all the time in any businesses, okay? So several factors we consider to analyze the cost for your materials. And the very first one is your cost per unit. okay, of your raw material. So that's the first thing you always consider. In addition, we consider cost for processing, cost for shipping, cost for storing, that's for inventory, and then the cost for disposing of that waste. Okay, so these are all the costs that we think about. Not going to go into detail in the first chapter, so try to familiarize yourself with all the new terms. Okay. All right. Source. So the next thing that we consider for selection of material, so we think about the source. Is it available in sufficient quantity? Sufficient meaning enough, all right, to do what you plan to do in your goals of your new product. Then we think about if it can be delivered in a timely manner, all right, to meet the production schedules. So there are many different kind of models, all right, for distribution. Then you think about if it is going to be reliable. Okay, I shouldn't say distribution, I should say supplies, okay, supply chains. So we think about all of that. The most important thing is you got to have enough, okay, you've got to have enough material, and you will select the material, okay, in order to develop your design in the amount that you want to manufacture. Okay, so these are everything that you have to calculate, think with your team, because otherwise you have to pay for more than you expected. The ultimate cost is going to be really bad, yeah, because the production delays, the alternate sources, trying to find them, that's very, very costly. Okay, so we don't want to go into that direction. So you have to do it right when you are doing planning, okay, or designing, which is really important in selecting the right material. Okay, it's got to be right. They got to be in a sufficient quantity that you want to fulfill your goals of that product. Okay. Environmental impact is the next factor that we consider in selecting the materials, because we live in the environment and you're producing the products, and that is going to be in the environment because there's nowhere else. It's just we have only this world, right? So you have to understand everything about your product because it will be interacting with the environment. So you don't want to choose something that is hazardous. Okay, we can't avoid this 100%, by the way, but you can alleviate. Okay, you can alleviate the intensity of that. So hazardous materials, you have to think about it. Percentages, so important. So think about the addictive, like your colorants, your stabilizer, your plasticizers, okay, toxic constituents like your lead is important thing, and cadmiums because they cause cancers, things like that. Okay, very environmentally not friendly metals. Okay, so biodegradability, you have to think about that as well when you choose the materials. So biodegradability is nothing but have ability to easily compose in nature without doing anything. Like banana, okay, banana skin. You can eat a banana and you can throw the banana skin out, they will decompose. Okay, you don't have to worry about it. You throw the plastic out, it's not going to decompose. Okay, because the materials that we make the plastic, okay, they're addictive. Okay, so therefore EPA usually lists the plastic in toxic, okay, hazardous material category. So because plastic, they constitute about like 28% of cadmium and also 2% of lead, okay, in the solid waste. So that's a big deal. But then plastic is so useful, okay, in manufacturing, in storage, in use. So people love that flexibility. People love the cheap things, okay, because they have the ROI is really high. So they choose this, okay, material to make their products, like the plastic bags. All the fast food, right, chains use this heavily. Fast food is one of the major industry contributing the highest waste. Okay, so anyways, right now there are too many issues, okay, environmental issues. Therefore, the selection of materials, we can't get rid of it 100%. That's a reality, okay? But we can mix, okay, composition that is going to reduce, okay, reduce the toxicity, okay, and reduce the level of addictiveness. Another one is polystyrene products, and they are completely non-degradable, okay, non-biodegradable, meaning like they won't decompose in nature. And that's another controversy and a real big issue in the world, ongoing, okay, issue in the world. All right. Then you need to understand the standard and specification in product development and when you're dealing with the industrial materials, okay? So standards they're just specifications, but they've been adopted, okay, for use by broad group of manufacturers, users, and specifiers, okay? So it's important to have standards because they're widely accepted measures, and we use them to compare qualitative and quantitative, okay, values. We also use them to determine, okay, manufacturing industry, determine what materials meet the requirements, because you always have to make your product within the requirements, okay, operational conditions and your environmental conditions and your desired quality. So we always reference the appropriate standards to make our products with the materials. So they have been established for the conversion. Okay, another one is you don't want to calculate again and again. All you have to do is just reference the appropriate standards, so you know, okay, what is the requirements for the conversion of raw materials to commonly accepted shape size. Okay, you can't just make whatever shape you want. You have to make shapes and size according to the accepted standard, okay, worldwide, to be valid, okay, to make your product valid in the market, because you have to be compliant to all these requirements, because it is governed, right, by private and also public sectors. So if you don't follow these rules, then you will get into trouble, right, nationally and also internationally. Okay? So we have our ISO standards, we have conversion standards, we have material conditions, environmental conditions standards, and you have to follow all these standards in manufacturing. So why? Because it's so important to facilitate the commerce, all right, domestic, nationally, and also internationally. Okay. This is just an example. You can see a bigger picture in the chapter handout. So this is just showing you, okay, a standard. So raw steel is processed into the billets sheets. So these are just shapes, okay, and the sizes that you want, okay, your product to be in. So it's just a type of standard. Then in the United States, the standards are there are two groups. Okay, one is a mandatory, and the other one is a voluntary with consensus. So mandatory standards are usually set by the government because they usually do policing, and businesses cannot just make whatever they want to do. Okay, they still have to conform these standards. All right, so two of them. One is a procurement standards. So that's requirements. All right, the government suppliers got to meet them. The other one is a regulatory for every one of us. Okay, so those are the requirements for your health, your safety, and the environment. Okay. The other category is a voluntary standards that goes by the agreement. Okay, and they develop through the participation of a group of stakeholders or interested stakeholders. So this is kind of loose, but this is completely mandatory and completely monitored, okay, by FBI and also CIA for the international affiliations. Specification is nothing but they're just a description, okay, or requirements and for your materials, your products and services in your business, okay. Something that you want your product to do comes with the specifications. So specifications usually state the requirements for your mechanical, physical, right, and a chemical property. So your strength, mechanical, physical, chemical, and dimensional properties. So these requirements are specified in documents. Okay, so you don't have to form again and again. So you have variations in product designs, but then we always refer to the historic specifications, okay, to make the new one or to update something. Okay, so these are pretty convenient if you have, like the historic specifications for all of your products or variations of your products. We refer them, use them. It's very handy. And they may state requirements for quality and the use of materials and methods, all right, to produce a desired product, system, application, or finish. So if you think about specification, you've got to understand the other requirements. I actually want you to get this, right? The middle one, mechanical, physical, and chemical, and dimensional stuff. If you think about the standards, these are just governing rules, okay, that are accepted by our country and also the world. And you will have to conform with these standards, okay? Because our market, even if we say it's a free market, it isn't 100% free. You still have to maintain the standard of your products, okay? Alright, so this one is just an example of specification. You don't really have to remember any of it. Just want to show you how we describe the specification according to a product design. Okay, drawing, you're going to take industrial metrology, but you will get a general idea of what they are. So here you have specification that we write in a particular way. Okay, for industrial material, then you know that we use a standard and specification in product development. Okay, the details are usually done by the product engineers, okay, design engineers. They draw this for you, and you are actually in the shop floor. You only have to know how to read them, okay? All right. Then we have standard and specification body, okay, the organization that governing these standards and specifications. So they're all private and public organization, and they make the standards, okay? And we use the standards to compare qualitative, quantitative values so we can judge our product quality. So the private organizations that establish, okay, those standards for materials and processes, we call them with common word trade associations, okay? And the organizations, these are the organizations of manufacturers and businesses, and they engage in the production or supply, okay, of materials and related services. So here are the examples of such organization trade associations. So American Iron Steel Institute, Engineer Wood Association, Plaster Engineer Society, National Association of Home Builders, your Asphalt Institute, Society for Automotive Engineers, your SAE, American Society for Metals, okay, and so and so. No need to remember any of that, okay. Here is just an example of a stamp, okay, of a trade association, APA. We already know what APA is in the previous slide, so that's your Engineer Wood Association. Okay. And this is for ASTM. I'm just trying to show you this book, okay, standard books. These are boring books. You only use it to take a look at, if your specifications are right or not. they're just hanging there in the maybe on your shelf, right? Usually very dusty. But anyway, so that's how we look it up. Because after you use one time, we usually write it down in our own computer, or sometimes we take picture of it every time you use it. But then nobody usually keep it and use it like all the time. We don't do that. You only use as a reference, okay, reference to check something. All right. So the functions of standards organization they're just services to the membership, okay, and also the public. So what do? We conduct the research related to the area of the interest. We review and establish the standards in the areas of responsibilities, and then we promote the work of the organizations. We educate, train the members, and also the stakeholders. So that's what the organization, trade association usually do, okay, their functions. Okay, that's it for today for this chapter. Sorry, this is unit 1, okay.